Hi mathematicians, today we will justify our thinking using knowledge of place value. We're going to really focus on our math practices today in our lesson. So I want you to look really closely at math practice number 3. Today we're going to be working really carefully on constructing viable arguments and being able to explain and reason why we agree or disagree with generalizations or statements. So, today's task, you're going to be given a generalization. A generalization is just a statement about math. Mathematicians call them generalizations. Once given a generalization, you're going to have to decide if you agree with the statement, disagree with the generalization, or do you agree and disagree because it depends on something? Once you decide if you agree, disagree, or it depends, you need to be thinking about how can you prove your thinking? How can you justify why you agree with something or why you disagree with something, and put it into words using mathematical numbers, symbols, and explanation. So let's try one together. Here's an example. If Miss J says each place value when moving to the left is 10 times bigger, do you agree with that statement? Do you disagree with that statement? Or do you think it depends? I'm going to give you some examples of some weak responses, some strong justifications, and then some even stronger ones. So here's an example of a weak response. Simply saying, I agree with this statement. It's weak because there is no justification. The statement does not explain why you agree with this generalization. Another weak response is, I think I agree with the statement because 10 is bigger than 1. Well, when you use I think in your statements, that shows that you're not confident with what you're telling us. So try to be very direct in saying, I disagree, or I agree, or I know. That way it sounds like you're confident in what you are about to tell us. Here's a little bit of a stronger statement. This is what we were aiming for as a 4th grader. Saying, I agree with this statement because going from the ones place to tens is 10 times larger than going from 10 to 100 is 10 times bigger. Here's an even stronger statement, a statement that perhaps we might see from a 5th grader. I agree with this statement because each time you move to the left in a place value chart, the number is 10 times larger. So 10 is 10 times bigger than 1, and 100 is 10 times larger than 10. The value of the digit 1 is also 10 times more when looking at 2 place values next to each other. So what makes the strongest response a little stronger than the strong response? Well, 1, it flows and it sounds more clear. It's easier to understand. But 2nd, they not only gave examples, but then went on to actually explain what the examples actually meant. So today, we want you to really focus on writing stronger responses. And if you really want to challenge yourself to write some strongest 5th grade responses. I want to give you a little new knowledge that we can practice with this year so you'll be ready when you get to 5th grade next year. A little preview, we'll call it. I'm going to give you a preview of powers of 10. We already said that using a place value chart and moving from the the ones to the tens is 10 times larger, and each time we continue to move to the left, so from the tens to the 100 is 10 times larger, from the 100 to thousands is 10 times larger, and so on. In fourth grade, we're really going to be working with some larger numbers, moving into the millions and the billions. But you can still remember that each time you move one place to the right, the place value gets 10 times larger. However, as we start to work with really large numbers, 10 times 1 is 10. 10 times 10 is 100. And you know that 10 times 10 times 10 equals 1,000. What if I want to do this 6 times? Then I have to write 10 times 10 times 10 times 10 times 10 times 10, which equals 1,000,000. And we know that mathematicians like to take shortcuts to be more efficient. So with powers of tens, they use exponents so they can write really large numbers like numbers in the millions and numbers in the billions quicker, so they can be faster, because mathematicians like to be fast when writing down their answers, their solutions. So if we go back to 10 times 1 and we want to use a power of 10 with an exponent, we would simply write 10 to the first power. And 10 to the first power equals 10 because you're just multiplying 10 one time, or there's 1 0. So the exponent, which is the smaller number up in the right-hand corner, is called an exponent, is a 1. If we look down at 10 times 10 equals 100, we could also write 10 times 10, or the number 100, as 10 to the second power. So our exponent would be a 2. I bet you can guess what 10 times 10 times 10, or 1,000, would be written in exponents. If you said 10 to the third power, you are correct. And what about our last one? If we wanted to multiply 10 6 times, or if we wanted to write the number 1,000,000, how could we write that using a power of 10 with an exponent? Say it. I bet you said 10 to the 6th power. So as we are working with large numbers, try to use powers of 10. Try to write a number with an exponent, and that will help to prepare you for 5th grade. All right, let's try one more together. Let's say that I say 10 to the 5th power is the same as 1,000,000. That's my generalization. That's my math statement. Do you agree? Do you disagree? Or does it depend? Well, a weaker response would be saying, I disagree. Again, it doesn't give us any reasoning. It doesn't tell us why you disagree. Another one would say, I think I disagree. Remember, when we use the words I think, it makes you sound like you're unsure of what you're about to tell us. So just be very direct and say, I disagree, or I know I disagree. Makes it sound more powerful. Let's look at some 4th grade statements. So a 4th grade justification might sound like this. I disagree with this statement because 10 to the 5th power is not equal to 1,000,000. It tells us that they disagree and they tell us why, but it doesn't have any further explanation or vocabulary like we're about to see in the strongest 5th grade response. Here it is. I disagree with this statement because 10 to the 5th power, or 10 to the 5th power, is equivalent to 10 times 10 times 10 times 10 times 10, which equals 100,000, which is 100,000 in words, not 1,000,000. So that's the strongest statement because not only did they tell us that they disagreed, but they also explained why and gave a very specific example. All right, mathematicians, it is your turn. I want you to think about each generalization today that we present you with, and I want you to think about how can you prove your thinking for each statement in a clear, concise response for another mathematician to understand. Off you go, mathematicians.